As you move forward in your mathematical career, what you're going to find is that in calculus classes, for example, there are going to be places where they're going to give you one logarithm, but once they ask you to do something in that calculus class with that one logarithm, you're going to realize I can't do what they're wanting me to do with the problem as written. So what you have to do then is take the one logarithm that they give you and break it up into lots of little logs. Now, we can also do just the opposite. You can be given lots of little logs, and then you can bring them together as one big log. So it all comes down to what kinds of things you need to do with this logarithm afterwards. So let's check out example 3. You'll notice in example 3 that they say, go ahead and take this one log and break it up into lots of little logs. And then there's a second sentence. It says, express powers as factors. So as we need that, I'll go ahead and refer back to that set of directions. So let's go ahead and check out part A. As you look at part A, we have log base 5 of 25x. Now, the first thing that you have to realize is how the 25 and the x are connected in this problem. The 25 and the x are connected by multiplication. So if it's helpful to you, go ahead and put a multiplication dot between those. Now that I have that, then I have a log of a product. Log of a product, I know that there's always going to be a connection between multiplication and addition. So this is going to be the same as the log base 5 of 25 plus the log base 5 of x. Once again, be careful. LOG is written once when it's written as the multiplication, but it's written twice when it's written as the addition. Now, as you look at this then, anytime you can simplify a log, you want to make sure that you do that. So log base 5 of 25, that's never going to be hanging out in a final answer because you can simplify that particular expression. So remember, log base 5 is simply saying, what's the power on your 5? So what's the power on your 5 that would give you an answer of 25? The answer is 2. So we have then 2 plus. This one though, log base 5 of x, I can't do any kind of simplification with that one. So it simply comes down as log base 5 of x. And there we have our final answer. So we have 2 plus log base 5 of x. Next off then, as you look at part B, once again you need to think about this in terms of how these two pieces in the argument are connected. The x squared and the square root are multiplied. So once I realize that that's a multiplication problem, I can go ahead and use my product rule. Product rule says that if I have a log of two things multiplied together, I can break that up and have log of x squared plus log of the square root of 1 minus x. Now that I have these then, remember that direction set up above that said express powers as factors. That statement is actually coming and talking about how they want you to leave the answer for something like log of x squared. So instead of leaving this power of 2 as a power, they're saying, oh, remember that property 7? Property 7 says if you have log of a power, you can bring that power down in front. So that's what they're saying. They're saying rewrite that 2 so that it is a factor in front of the logarithm instead of leaving it as a power. So there it is. We've written our power as a factor. So we have 2 times log of x. Well, we can play the same game with the second piece. So remember that the square root is in fact associated with a power of 1/2. So let's bring that 1/2 power down in front. So it's going to be 1/2 log of 1 minus x. Now, at this point, some of you are going to be tempted to do something bad. So we need to talk about it and make sure that you're comfortable with why we can't go there. Some of you are going to say, ooh, there's a subtraction there. And I remember that there's a connection between subtraction and division. But remember that warning that I keep on giving you? You have to make sure that you have the right number of LOGs. So if you look at this LOG associated with that subtraction, I only have one LOG associated with that subtraction. If you look at property 6, what you're going to find is that property 6 has 2 LOGs associated with the subtraction. I don't have enough LOGs associated with that subtraction in order to use property 6. So what that means then is I can't do any more on this particular problem. So if you looked at this problem and you said, I think that this is a property 6 problem, make sure that you make a note to yourself off to the side that says, I cannot make a connection between this subtraction and the division because I don't have the right number of LOGs. Now, other people want to do something else. They want to come in and say, oh, the log of this piece, 1 minus x, I can break that up as the log of 1 minus the log of x. That's actually not true either. So when you're looking at these kinds of arguments, you can't simply come in and think about this log in the same way that you would think about the number 5 and try to distribute that 5. Log is the name of a function, so you can't distribute the name of a function and bring this into both of those. So in fact, if property 6 doesn't work, and I can't think about this in terms of distribution, I'm actually done with that problem. So there it is. My final answer on this particular problem then is 2 times log of x plus 1/2 times the log of the quantity 1 minus x. Well, now let's go ahead and check out part C. For part C, I have the natural log of a division problem. Well, this time it is actually going to be property 6. When I have one copy of the log and I have a division, I can rewrite that in terms of a subtraction. Now, I have to make sure that the base of the log is going to be the same when I write down that subtraction problem, so I need to have natural logs. So it's going to be natural log of e to the x, my numerator, minus natural log of x, my denominator. But remember the comment that I made just a moment ago. Anytime you can simplify a log, you need to do that. So natural log, once again, is simply saying, hey, what's the power on your e? Power on my e, when I look at e to the x, is x. So this is going to be x, and then minus natural log of x. I can't do anything else with that piece. So there's my answer, x minus the natural log of x. Now for part D, we can have a whole bunch of things happening all together. But it really just becomes the same things that we were looking at, just more steps along the way. So the first thing I notice on part D is that I have a big old division problem. Big old division problem can be rethought of as a subtraction. So, okay, let's do that. So we have log, and again, it has to be the same base. So up here it's a common log, so I'm going to have a common log down here as well. So we're going to have log of my numerator, and that's going to be x to the third times x minus 1, minus the log of my denominator. So log of, and then it's x plus 2 quantity squared. Now that I've broken it up using the quotient rule for logarithms, I can look at each one of these individual logs and say, hey, I can do more. So as I look at my first logarithm, notice that the x to the third and the x minus 1 are connected by multiplication. Because they're connected by multiplication, I can use the product rule for logs. Now, in order to make sure that I have enough space here, I'm going to go ahead and do some erasing and then do some expanding here. So, okay, if we're going to come in and break this up using the addition ideas, I know that there's a connection between multiplication and addition. So this is going to be log of x to the third plus log of x minus 1. Now, one more time. Notice that I have one copy of the log when it's a multiplication problem, but I have to have 2 copies of that log when I break it down into the individual addition pieces. And then over here we have minus log of x plus 2 quantity squared. Remember in our directions, though, that it said express powers as factors. So I can't leave this x to the third as it stands. Anytime I have a log of a power piece, I can bring that power down in front. So let's go ahead and do that. Bring the power down in front. We have 3 times log of x. Then we have plus log of x minus 1. And then over here, I have the same thing going on. I have a power there. I have an exponent of 2. That exponent of 2 can go down in front. So it's going to be minus 2 log of x plus 2. Now, as you look at my last 2 logs, once again, be careful not to try to break those down further. So, one more time, I cannot distribute this log because it's the name of a function. So it's not log of x minus log of 1. That doesn't work. And it's also not going to be associated with property 6. I can't take this subtraction and rewrite it as a division because I just don't have the right number of logs associated with that subtraction. So, in fact, I'm done with this problem. So, final answer for part D, we have 3 times the log of x plus the log of the quantity x minus 1 minus 2 times the log of x plus 2. Now, as you look at this, some comment that I need to make at this point is that you'll notice that I'm using parentheses in some places but not others. So notice here, I don't have parentheses around that x because they're not absolutely required. But I am putting parentheses around this one because there I do have to have those parentheses to demonstrate the idea that this entire expression, x minus 1, is the argument of the log. So anytime I have the parentheses, that's telling you something special about how those pieces are connected. So yes, we do have to have the parentheses here, once again, to demonstrate the fact that x minus 1 is the argument of that log. And the same thing about the x plus 2. I have the parentheses around the x plus 2 to demonstrate that that whole thing is the argument of the log. If you don't have the parentheses there, it doesn't tell you the same thing. So anytime you have something that is just a one-termed argument, you don't have to write down the parentheses. And that is a tradition that I follow. So one-term pieces, no parentheses. But anytime you have something more exciting, I tend to put those parentheses, and in particular, anytime you have a subtraction or addition, you definitely want to use parentheses for your arguments.